Hello, guys, and welcome to today's live stream. I'm glad you decided to join. So let's just give ourselves some 2 to 3 minutes for others to join, and then we can start. So today we'll be dealing with the topic dimensional equations in physics. This is what today's live stream is all about: dimensional equations in physics. This is one of the basic things you need to know in physics as you go on your journey to learn physics. So let's use this opportunity to give a like to the live stream, comment Shakin Hour in the comment section, or just drop some fire in the comment section or in the live chat, and then use this opportunity to share the video with friends and colleagues as well, so that they will also enjoy this opportunity. All right, so like I said, we'll give ourselves some 2 minutes exactly at 8:03, then we start the live stream. Now, I also want us to use this opportunity to ensure that we share the video with our colleagues, but also comment the topics we would like uh, for me to treat in the subsequent weeks. For this week, we'll focus on physics. Then next week, we'll focus on mathematics. Then after that, we'll focus on chemistry. So a week we take one major topic subject, physics. If it's physics, we do physics the entire week. If it's biology, we do biology the entire week. If it is chemistry, we do chemistry the entire week. Okay, so exactly at 8 today we will start uh the lesson. But as at now, let's use this opportunity. Let's like the video. Let's comment some fire in the comment section so that I know we are here watching. And also let's share or invite more people to join. Today we are treating physics. Like I said, we are looking at dimensional equations. Dimensional equations. All right. Okay, so it's time, and let's start with today's live stream. So like I said, we are looking at the topic or the subject physics, and under physics we are looking at what we call dimensional equations. That is what we will be treating in today's live stream. So let's go ahead and begin. Dimensional equations. Dimensional equations. So dimensional equations. Okay, so this is what we will be treating in today's video. Now, when we talk about dimensional equations, what are dimensional equations? So a dimensional equation is an equation which expresses a physical quantity in terms of its dimensions. So when we talk about a dimensional equation, we are saying that a dimensional equation is an equation which expresses a physical quantity in terms of its dimensions. Okay, basically what it means is that when we have a quantity in dimensional analysis, we express it in terms of their dimension. What we mean by that is, let's look at the three fundamental quantities that we have. So the three fundamental quantities that we have mass, we have length, okay, and then we also have time. Now, so if you look at these quantities and want to express them in their dimensions, this is what we have. So for instance, let's have this table. We have the quantity here, and then we have the dimension at this side. Okay, now for this physical quantity, let's look at mass. So for mass, it is measured in kilogram, but the dimension of mass is just the m that starts. So you use capital M. That is the dimension for mass. For length, which is measured in meters, the dimension for length will be L, just L. And then the third quantity is time, which is measured in seconds, but its dimension here is capital T. So what it means is that whenever we have any quantity at all, being it force, pressure, or anything, we try to break them down into these three basic physical quantities. And after we break them down, we write them in this format, or we write them in their dimensional format. And this is what we mean by dimensional analysis. Now, this has a couple of uses which we'll be looking at later on. But for now, let's say we want to write the dimension of mass. How do we express that? So if I just write mass, this is ordinary mass, but the moment I put it in this straight bracket, it means the dimension of mass. So in this case, this will be equal to capital M. Another example, let's say I want the dimension of length. Okay, to show that I am saying dimension of length, I put it in this brackets, and therefore the dimension of length in this case will be L. The same thing with time. If I want to find the dimension for time, I just put it in this bracket, and then I write the dimension for time as T. So these are the dimensions of the three physical quantities that we have. We have M, L, and T, and these form the basics of all other dimensional analysis. Now let's look at an example to really appreciate what we are doing. So we have the first example over here. So we have example. So this is example number 1. The question says, what is the dimensional equation for speed? So what is the dimensional equation? What is the dimensional equation for speed? Okay, so let's go ahead and look at the dimensional equation for speed. So we write down our solution. Let me use black to write. Now, the formula for speed, when we write speed, the formula for speed is equal to distance over time. This is the formula for calculating speed. Now, if we want to find the dimension of speed, what it means is that we'll put this bracket around the speed. It means we are trying to find the dimension of speed. So I will apply that to the distance and then the time as well. So it means I want the dimension for the distance, and then I want the dimension for the time as well. So this is how I write my expression. Now we need to note that distance is a form of length. So whether distance, whether breadth, width, or height, all these are all length. They are all length. Okay, length measured in a different direction gives you this. Okay, they are all length. So for these guys, distance, breadth, width, height, all of them are a type of length, or they are length, and so therefore their dimension is just L. So in this case, the dimension for speed over here, like I said, we already saw what is the dimension of time. So the dimension of distance over here at the top is L. Then over the dimension of time is T. T for time, the first word. So it is T over here. So this implies that the dimension of speed if I rewrite the expression that I have over here, that is, I bring the t to the top, the dimension of speed will become lt minus 1. So this is the dimension for speed. Now, if you don't understand, you can let me know in the live chat comments. If you want me to go over something, you also let me know, and then I'll go over. But for now, this is what we have. This is the dimension for speed. Like I said, if you have any question, drop it in the live chat, and then I will try to explain. But for now, this is the dimension for speed. It is lt minus 1. lt minus 1. Very good. Now let's proceed to look at another example. So let me quickly erase this. So let's look at another example. Now let's look at another example, acceleration. Acceleration. Now let's find the dimension for acceleration. Are we okay? Now, for acceleration, the formula for acceleration is equal to velocity divided by time. Are we okay? Now, to find the dimension for acceleration, it means that I have to put it into this bracket. It means I'm finding the dimension for acceleration, which is equal to the dimension of velocity over the dimension of time. Now, let me take this one after the other. Let me take velocity first, and then I'll take time, and then we combine it back together. So if I take velocity, the formula for velocity is displacement over time. Displacement over time. It is a vector quantity. Okay, so the velocity alone, just the velocity at the top over here, that alone, this is the formula for velocity. It is displacement over time. Now, displacement is a type of length. Are we okay? Or it measures length. So the displacement over here, the dimension for it is L over the dimension for the time over here is, as we've known so far, is T. So for velocity alone, the dimension for velocity is LT minus 1. That is, I'm bringing the time to the top. So this is just for velocity. And time over here, this one, we know time, the dimension for time is T. That of velocity over here is what we are saying is LT minus 1. Are we okay? So therefore, it means that the dimension for acceleration is equal to velocity, which is LT minus 1, over time, which is T. Now, mind you, once we found the dimension for the quantity, we no longer bring this square brackets. Okay, we no longer bring it. So this is what we have. And if I send the T at the bottom to the top, it becomes LT minus 1, T minus 1. And in indices, we know that once the bases are the same, you add their exponents. So I have here LT minus 1 plus minus 1 will give me minus 2. So this becomes my dimension for acceleration. So for acceleration, the dimensional equation is LT minus 2. LT minus 2. Very good. So that is the dimension for acceleration. Now let's go ahead and look at the dimension for the following quantities. So let's find the dimensional equation for the following quantities. Find the dimensional equation So let me so we have to find the dimensional equation of A, force, B, pressure, C, density. Okay, so let's find the dimensional equation for the following. So we'll find that of force, pressure, and density. Very good. Now let's proceed to look at the dimensional equation for these particular quantities. Now at this point, if you've gone through everything I've been teaching so far, what it means is that for you to be able to succeed in writing the dimensional equation of a particular quantity, all you need to know is the formula. Once you know the formula for that particular quantity, you can break it down into the three basic quantities and then you give them their appropriate dimensions. That is what this implies. So for instance, if we look at force over here, let's look at the solution for that of force, the dimension or the dimensional equation for force. So for force, the formula for force is mass times acceleration, or mass multiplied by acceleration. The acceleration can either be linear acceleration or acceleration due to gravity, but they are all the same. In this particular case, in dimensional analysis, they are all considered the same. Now, what it means is that to find the dimension for force, I put them in this square bracket, and I do the same for the mass, then I do the same for acceleration. Now from here, I'll take these individual quantities one after the other and find their dimensions. Now for mass, it is obvious m. It is obviously m. For acceleration, we've already looked at that, but let's do it again, just for sake of demonstration. So for acceleration, we know that acceleration is velocity over time. And then so far, we've established the fact that velocity is Lt minus 1 over time, which is also t over here. So if I send the t at the bottom to the top, this becomes Lt minus 2. So it means that my force, which is equal to the product of mass and acceleration, the acceleration is, the dimensional equation for acceleration is Lt raised to the power negative m. So if I combine this, it means that the dimensional equation for force is equal to m multiplied by Lt minus 2. And if I join all of it together as a dimensional equation for force, then I now get mLt minus 2 as my answer, or as the dimensional equation for force. So I believe so far we are understanding, and so far this is making sense. Very good. Now let's look at the next example, which is pressure. Pressure. So for force, we are saying it is mLt minus 2. Now the next one, let's look at it, which is pressure. So let me quickly erase this, and then we continue. for pressure, the formula for pressure is force over area. This is the formula for pressure. So for us to be able to find the dimensional equation for pressure, we bring our usual symbol to indicate that we are finding the dimensional equation for pressure, which in this case will be applied for that of the force as well and that of the area. Now, if you look at it, we have two big quantities over here that we need to break down one after the other to be able to get the dimensional equation for pressure. So let's take it one after the other. The force was what we did in the previous example. But just to go over again, the dimensional equation for force is that of mass multiplied by acceleration. And we've already established the fact that for mass, the dimensional equation for mass is capital M. And then that of acceleration is velocity, will give us LT minus 2 for acceleration. So therefore, the dimensional equation for force is equal to MLT minus 2. This is the dimensional equation for force. Now let's look at the second one, which is the area. So the dimensional equation for area is length multiplied by breadth, or someone will say width. It's the same. So in this case, we find the dimensional equation for this. So for area, this is equal to length and breadth. Like I said earlier on, they are the same thing. Length and breadth are the same thing. So for length, I write capital L multiplied by breadth is also a type of length, so it is also L over here. So from here, all I need to do is to multiply the 2L to get my answer. So I'll get L squared over here. That's my answer, L squared. So the area over here, the dimensional equation for area here is L squared. That is for area. Now all I have to do is to bring this back over here. So therefore, my dimensional equation for pressure is equal to that of force is what we have over here. We have MLT minus 2 divided by area is L squared, which is over here. So from here, one of the L can cancel one out here. So one will cancel one here. So we are only left with one L. So therefore, we have MT minus 2 divided by L. And when we send the L to the top over here, this is what we will get. We will get M. The L will come to the top, will become L minus 1. And then the T will have minus 2 as the power. So therefore, it means that the dimensional equation for pressure is equal to ML minus 1 T minus 2. This is the dimensional equation for pressure. I hope so far we are understanding and this is easy for us to grasp. This is how Sharking Hour is going to be. I will take my time, explain difficult concepts into easier way. Now, because this is just the second live stream, we are taking the basics of physics. But along the way, we'll be looking at more complicated stuffs where you guys will be forced to be asking a lot of questions whilst we go on. All right. Let's look at the next quantity. Let's look at the next quantity. In this case, that is density. So let me quickly get some space and then we proceed. All right, so guys, let's use this opportunity. Let's like the video, let's share, let's comment, let's drop some fire emojis. Just type hashtag Sharking Hour. All right, so let's proceed with the third example, which is density. Now, the formula for density is mass over volume. Mass on volume. That is the formula for finding the density of an object. Now, to find the dimensional equation for this, it means we write it like this. The dimensional or the dimension for density is equal to the dimension of mass divided by the dimension of volume. Okay, now as always, we will take the dimensions of these quantities one after the other, and then we combine it later. For mass, the dimension for mass, as we already know, is just m. This one, there's no doubt about it, it's just m. Now let's look at the second quantity. In this case, that is the volume. So let's find the dimension for volume. Now for volume, the formula for calculating or finding volume is length multiplied by breadth or width multiplied by height. Multiplied by height. This is how you find the volume of a quantity. So it means that all we have to do is to add this straight bracket around it. So it means the dimension of length, the dimension of breadth, the dimension of height as well. So therefore, the dimension of volume will be equal to length is L, breadth is also a type of length, so it is also L, height is also the same, which is also L. So therefore, for volume, the dimension or the dimensional equation for volume will be L raised to the power 3 or L cube. That is the dimension of volume. So if we combine these two together, for mass at the top is just capital M, for volume at the bottom is L cube. So this will be equal to M L raised to the power minus 3, because we are moving the L cube from the bottom to the top. So this becomes our expression for density. So this means that regardless of the quantity that you've been given, once you can break that quantity into simpler units, okay, or the basic units, you will be able to break it down or write its dimensional equation. So over here, the key emphasis is know the formula. Know the formula. If it's possible for you to memorize the dimensional equations of these quantities in your mind and you don't have to remember the formula, that is okay. But should you be asked to show work, it will become a problem. So you need to know how to state the formula. And once you know how to state the formula for mass, for pressure, for area, for volume, for these quantities, once you know how to state the volume, the formula, you should be able to find the dimensional equations very easily. And this is what we are saying is all about dimensional equations or analysis. Okay, so at this point, I will wait for some question. Let's give ourselves some 2 minutes for you guys to ask question. If you don't have any question, then we move to the uses of dimensional equations, where you actually see how relevant this is in real life or in application, the application of dimensional equations, and what we'll be looking at next. So I'm waiting for your questions. Okay, so in the absence of any question, let's look at the uses of dimensional equations. So uses of dimensional equations. Now, the first uses or the first use of a dimensional equation is you can use it to find the units of quantities. Okay, so you can use it to find the units of quantities. So we'll be looking at that, what we mean by this, and how you'll be able to use just the dimensional equation to find the SI unit or the units of a particular quantity. We'll be looking at that next. Now, the second one is to check the validity of an equation. You can use it to check the validity of an equation. Okay, so you use it to check whether the formula or a formula that you generate is right or wrong. Okay, that is what we mean by the validity of an equation. And then the third one is to derive an equation between quantities. So derive equation between quantities. Okay, now how to use dimensional equation in deriving equation between quantities. We'll be looking at this tomorrow for our next live stream. So this will be done tomorrow. It will be treated tomorrow. Are we okay? But for now, we are going to be looking at how to use dimensional equations to, one, get the units of quantities, and two, to check the validity of an equation. Are we okay? So let's look at the first one, how to find the units of a particular quantity. Now let's look at an example. Okay, so I am to find the units of the quantity whose dimension is. So find the units of the quantity whose dimension is MLT minus 2. All right, so over here in this particular example, we've been given the dimension, and from the dimension we are supposed to come up with the unit or the SI unit for that particular quantity. Now, if we look at the dimension, we have MLT raised to the power negative 2. Now, we know from our dimensional equation that we've learned so far that M is for mass, okay, and mass is measured in kilogram. This is the unit for mass. This is the unit. This is the dimension. Don't get it confused. This is the dimension for mass, and this is the unit for mass. There's a difference between them. Now, for L, it stands for length. Okay, either length, breadth, or height, or displacement, or distance, they are all considered as length. And then they are measured in meters. For T, it is time, and then time is measured in seconds. So if I look at the unit over here, all I have to do is to combine these three to get the unit of this particular dimensional equation. So what it means is that my M over here, which is the mass, the SI unit or the unit is kilogram. For the length, it is meters. And then for the time, it is seconds. So seconds, and then I bring the power negative 2 over here. So if you look at it, let me use different colors. The M goes for kilogram, the L goes for the meters, and then for the time goes for the seconds. The time is for the second. So in this particular case, our answer, which is or the unit for this particular quantity, is kilogram meter per second square. So this is the unit. Are we okay? All right. Now let's look at another example. So let's find the unit of the following dimension: velocity and pressure. Let's find the unit or the measuring unit for these two quantities. So one, we are looking at velocity. So let's say you've done a calculation on velocity, and all of a sudden you don't know the SI unit for velocity. How will you be able to write the unit? Because if you just write the answer without the unit, it's wrong. So how will you come up with the unit on the spot? This is how this is one of the application of the dimensional analysis. So from just the dimensional analysis, you should be able to write the unit. So let's look at pressure. Okay, let's even add more. Let's look at that of force. Let's look at area. Let's look at density as well. Density. Okay, so we have to find the unit for these quantities. So find the unit. We have to find the unit for this quantity. So I for velocity. Okay, now we know velocity. The formula for velocity is displacement over time. And we said that if we find the dimension of this, the dimensional equation for velocity, the displacement is L over T, which is LT minus 1. So this is the dimension for velocity. By now, we should know how to generate this. Now from here, all I have to write is for length, like I said, length is measured in meters. So here is M as the unit. The time, which is T over here, is measured in second. So I'll write my second and then I bring the power negative 1. So it means that the unit for velocity is meters per second. That is the unit for velocity. Okay. Now, since we are here doing velocity, let's do acceleration as well before we move to pressure. Let's do acceleration. So let me use this as II bonus acceleration. Okay, so for acceleration is velocity over time. Okay, and we already know that velocity is LT minus 1, so I'll just write that straight. So LT minus 1 divided by the time, and so therefore the dimensional equation for acceleration is LT raised to the power minus 2. Now from here, what it means is that my L, which is the length, is measured in meters, so I write M. My time, which is T over here, is measured in what, seconds, so I write my seconds, and then I bring the power minus 2. So acceleration is measured in what? Meters per second squared. That is the the unit for acceleration. I hope this is making sense. All we are trying to do is that we are trying to generate the unit of measurement, okay, or the units for these particular quantities from their dimensions. We are getting the units from the dimensions. That is what we are doing. All right, let's look at another example. Let's look at the third one, pressure. So for pressure, we said pressure is equal to force over area. And then we are saying that for force, it is mass multiplied by acceleration. Acceleration as the formula, and then all over area. So therefore, it means that for pressure, for force, my dimension is, for the mass is M. Acceleration is, we already have it, LT minus 2. So here's MLT minus 2. And then the area is L squared. So this will cancel one of these. So for pressure, our dimension is M, L raised to the power minus 1, T raised to the power minus 2. This is the dimension for pressure. Now, to derive the units from these, we know as usual, here is mass. Mass is measured in, don't confuse the capital M over here with meters. No, this is the dimension for pressure. So let me write it here. This is the dimension for pressure, okay, and this is the unit that we are deriving from the dimension. So here's the unit. Over here, the M here stands for mass, and mass is measured in what? Kilogram. The L here stands for length, and length is measured in meters. So I write meters, and then I bring the power -1, and then the time is in seconds, so I bring the seconds power -2. So this is the unit for pressure. I know the standard unit is Pascal, but should you forget in an exam and you don't know that you've forgotten that the SI unit for pressure is Pascal, you can write this unit and it is also correct. Are we okay? There are instances where you'll be under examination pressure, you forget some of the SI unit. And mind you, the SI unit or the unit carries extra mark, or sometimes you will not be awarded the mark. So let's say you are done calculating the pressure of a particular um, question. You are asked to find the pressure, and you find the pressure as 20. So instead of writing 20 Pascal, you just wrote 20 instead of writing 20 Pascal or 20 kilogram per meter per second squared. You just wrote your answer as 20. The teacher can give it to you wrong because there is no SI unit or unit attached. Is it 20 meters? Is it 20 Fahrenheit? Is it 20 degrees Celsius? We don't know. So if you add the unit Pascal or this, then you are right. Are we okay? And I'm saying that there are instances where you may forget that pressure is measured in Pascal or any other, let's say, force. You may forget that force is measured in newtons. You may forget that force is measured in Newton or newtons, right? Now, should that happen, okay, from the dimension, you can derive the SI unit or unit for it, and then that will also be correct. And that is why we are learning dimensional equations, or that is one of the applications of dimensional equations, okay? So far we've looked at the unit of measurement for velocity, we've looked at that of acceleration, and then we've also looked at that of pressure. So I took my time to break the quantities down into their dimensions first and then converted it into the unit. The same way for acceleration, this is the dimension, and from the dimension we're able to get the unit. The same way for velocity, this is the dimension and this is the unit. Are we okay? So now we are left with force, area, and density. So we are left with force, area, and density to do. So let's quickly look at that. So let me erase what we have here and then we continue. Okay, now let's look at the third one that we have. I'm not sure blue might show well, so let me go for a darker one. Okay, so we have force. So I'll start by first finding the dimension for force, and then we proceed from there. Okay, so like I said, force is mass times acceleration. So we have mass multiplied by acceleration. Now at this point, some of the dimensions of the basic quantities should be in your head. For mass, it is m. For acceleration, it is lt minus 2. So for force, the dimension is, or the dimensional equation is mlt raised to the power minus 2. This is the dimension. So let me bring that over here. This is the dimension of force. So for the unit, The M over here is mass, and then the mass is measured in kilograms. The length, the L over here is length, which is measured in meters. And then the time as well is measured in seconds, and then you bring the power over here. So this is the unit for measuring force. Okay, and this was derived from the dimension. You don't need to go through the process of generating or writing the dimension. Once you know it all fed, from there you can get your unit from it. But in case you have forgotten, it's better to go through this process, less than 30 seconds or 1 minute. You get your unit, you add to it, and you proceed, than for you to just leave your answer without a unit and get it wrong. Are we okay? Maybe that 1 mark or that half mark might make the difference between you getting an A or a B plus or a B. Are we okay? All right, let's look at the next one, which is area. Like I said, for area, it is length multiplied by breadth. Please keep your comments coming and I will address them. So we have length multiplied by breadth as area, and then length is L, and then breadth is also L. So for area, it is L squared. That is the dimension for area. And then from the dimension, we can get a unit. Then the unit over here, L squared, length is measured in meters. So for area, it is meters squared. Okay, so we've been able to obtain the unit from the dimension, and that is what we are talking about. So let's quickly look at density, and then we proceed to how to check the validity of an equation using dimensional analysis before we end this today's live stream. And then tomorrow we will continue with how to write an expression or how to derive an equation between quantities using dimensional equations. All right, let's look at the next one, which is density. So we have here density. So density is equal to mass over volume. So it means the dimension of mass over the dimension of volume. Then from here, mass is m, volume is L cubed. So the dimension over here is ml raised to the power minus 3. Are we okay? Or let me write it here, ml minus 3. This is the dimensional equation for density. Now for the unit, to obtain the unit from here, mass is in kilograms and then length is in meters. So we add the power. So kilogram per meter cube is the unit for density. So far we've looked at how to write dimensional equations for quantities like velocity, acceleration, pressure, force, area, density. We have more. We have moment, momentum. All those quantities you can find or write their dimensional equation using the same approach as we have discussed so far. And we said that we have three uses of dimensional equations. One, we can use it to find the units of quantities, which is what we just finished doing. And then the second one, we are saying you can use it to check the validity of an equation, which is what we'll be going to look after, right after saying this. This is the next thing we'll be looking at. And then the third one is how to derive equation between quantities, and that will be done tomorrow during our third live stream. Okay, so let's proceed with how to check the validity of an equation. Are we okay? That is the next one we are going to do. So let me quickly erase everything on this space and we proceed. Okay, so this is a question for us. So let's say we have an example. We are to check the validity of the equation. Check the validity of the equation. Check the validity of the equation. V squared is equal to U squared plus 2AS, where V is equal to final velocity, U is initial velocity, A is acceleration, and then S is distance. So this is the question. So we've been told, or we've been given, the equation V squared is equal to U squared plus 2AS, and then we've been asked to check the validity of this particular equation. Now, to check the validity of this equation, what it means is that you write the expressions given to you in terms of their dimensions, and then you compare the left hand side to the right hand side and see if the dimensions are the same. Are we okay? And that is how you check the validity of an equation. So let's proceed to look at the solution to this problem. Apologies. So the equation we have here is V squared is equal to U squared plus 2AS. Now, both V and U are velocity. Okay? There's no difference between final velocity and initial velocity when it comes to dimensional equation. Okay, when we are dealing with kinematics, they are different. Okay, because depending on how you are looking at it, one will be negative or zero, one will be positive or zero. Are we okay? But they are all a form of velocity, and we've established the fact that the dimension for velocity, okay, which is distance over time. At this point, we've been repeating these equations to the point where even if you don't know now, you know it off head. Now, distance is L, time is T, so it becomes LT minus 1. So it means that the dimensional equation for velocity is LT minus 1. So in place of just the V, not the squared, V, I will write LT with the power minus 1 squared. Then this is equal to initial velocity is also the same. I have LT minus 1 squared, then plus 2 into bracket for A, which is the acceleration. We'll write that one over here very soon. But the S, they say, is distance, and distance is a form of length. Are you okay? And so therefore it is just L, so we write that one over here, L. Now let's look at acceleration. Acceleration, let me do that here small. Acceleration, we are saying acceleration is equal to what? Velocity over time. So if we find the dimension of this, we already have velocity over here, which is LT minus 1, and then the time at the bottom is here. So the dimensional equation for acceleration is LT raised to the power minus 2. Okay, so if I insert this into the place of A over here, which is the acceleration, I'll have LT minus 2 over here. Now, very good. Let's proceed from here. So from here, all I have to do is that the power over here will affect everything in the bracket. So here will become L squared T negative squared. Okay, or T raised to the power negative 2, because the 2 will affect everything in there. So we have L squared T negative 2 on the left hand side, and then this is equal to, on the right hand side we'll have the same thing. The 2 will multiply the 2 components in here, so we have L squared here T raised to the power minus 2 plus over here the 2 is outside, here I have L and L. Okay, the bases are the same, and then we are so we'll add the exponent. So here will become L squared and then T minus squared. Are we okay? This and this will now pair up to add up to each other. Are we okay? The L and then the L over here. Now, from here, what it means is that we have, I maintain here, L squared T minus 2. I maintain here as well, plus 2, then, sorry, let me quickly erase this guy, and then we do something over here. Now, if you look at this, we have here L squared T minus squared. Here is also L squared T minus squared. Then if you use the 2 to multiply it, here we'll just have L squared T minus squared plus 2L squared T minus squared. Now, if you look at it, here is L squared T minus squared. Here is also L squared T minus squared. It's just like A plus 2A. The L squared T minus squared are the same for both sides. So here, L squared T minus squared plus 2L squared T minus squared will give us 3L squared T minus squared. And then over here, we'll maintain here L squared T minus squared. Now, if we look at this, the 3 over here is what we call the coefficient. Our emphasis is not on that. Our emphasis is just on the dimension. So the dimension we have over here is L squared T negative squared. Over here, we also have L squared T negative squared. So therefore, we conclude that because the dimensions on the left hand side is equal to that of the right hand side, the expression v squared is equal to u squared plus 2as is valid, or is correct, or is a valid expression. Mind you, in dimensional analysis, our emphasis here is not on the coefficient or the number in front of the dimensional equations, but just on the dimensions. Are we okay? There are instances where you might do it, and then the dimensions on both sides can be MLT minus squared is equal to MLT minus squared without any number in front of any of them, whether on the left hand side or on the right hand side. But in some cases, you see a factor in front of one of them. But like I said, the coefficient is not what we are interested in. We are only interested in the dimensions on the right hand side as well as the dimension on the left hand side. So this is a typical example of how you check the validity of an equation. You note the parameters. In this case, we've been told that the v is final velocity, as we can see over here. The u is initial velocity. We've been told that the small a is acceleration. Then we've also been told that the small s is distance. So we break this thing down. We are saying velocity is lt minus 1. This one is also lt minus 1. Acceleration is lt minus 2. And then the distance is l. So we substitute these dimensions into these equations, square them, and then do basic arithmetic. And then this is what we came up with. L squared t minus squared is equal to, here we have 3 as the coefficient in front, but the dimension is still L squared t minus squared. And so therefore, because the left hand side is equal to the right hand side, we are saying that this equation is valid. Are you okay? So at this point, I will wait for questions. If we have any questions, let's ask. If not, then we'll end today's live stream over here, and then we'll continue tomorrow where we will use dimensional analysis or the dimensional equations to find equations between 2 or more quantities. Any questions from our live audience watching us? All right. So if there are no questions, thank you so much for joining today's live stream. I hope you found these live study sessions very helpful. For now, we are just looking at some basics in physics, and then I am teaching. From time, we'll start looking at past questions, SAT, which is the SAT, the JAMB, the WAEC past questions, the Cambridge past questions. We'll be looking at all these past questions with time. Will be okay. We'll be doing live Q&A sessions. We'll also be doing some giveaways in the future and other pop quizzes and other stuff online once we begin to get more audience joining us. So thank you so much for joining Shacking Hour. This is the second episode of Shacking Hour, and today we looked at dimensional equations. We are saying dimensional equations are equations expressing quantities in terms of their dimensions. And then we said that this works with the three basic quantities that we have, which is mass, uh, distance or length, mass, length, and time. For mass, the dimension of mass is just the first letter starting it, which is m. The dimension of length is l, and then that of time is t. Are you okay? So once you've been given a quantity, say pressure, you express it, pressure is equal to force over area. Then you break down the force, which is also equal to mass multiplied by acceleration. And then you also break down the acceleration, which is equal to velocity over time. You break them down and express it in these three physical quantities, which is mass, length, and time. And then you'll be able to write their dimensions and combine them together to get a final dimension of that particular quantity that you are looking at. And then we also stated that we have three uses of dimensional analysis. We may have more, but for now we are only looking at three. The first one is to find the units of quantities, which we saw how we can do that. We also talked about how to use dimensional equations to check the validity of an equation, which we also looked at, which is still on the screen. And then the last one we spoke about is how to derive an equation between quantities, and that is what we'll be looking at in tomorrow's live stream. So thank you so much for joining today's Shacking Hour from 8 p.m. to 9 p.m. It has been an hour, and I really enjoyed the sessions, and I hope you also enjoyed the session. So thank you so much for joining our today's lessons on dimensional equations in physics, Shacking Hour episode 2, Wednesday, July 2nd, 2025. So thank you once again, and I will see you in the next live stream. Bye bye.